Okay, this is one of those questions people love asking. It's because it's a little confusing, also requires a little bit of thinking. That's why people love asking this question, and now I would like to solve with two different ways. First one is natural way, using by tree method. The second one is Bayes theorem. Now, so first, notice that we have two coin, fair and unfair, right? Fair and unfair. What's so both have equal chance. That means 1/2 and 1/2 both get a 1/2 probability to be selected. Okay. Now, if we have fair coin, then probability of that we get tail is 1/2, but it's if 5 times, that means 1/2 to the 5, right? Now if we have unfair coin, then because both sides tail, then probability of 5 times shows up is 1 to the 5, which is just 1. Now the question is asking, what's the chance that we are indeed flipping the unfair coin? So this is telling us this part is total, right? The whole thing is total, but we consider this one. So what we do is 1/2 times 1/2 times 1 divided by total probability, which is 1/2 times 1 plus 1/2 times 1/2 to the 5. Okay, so that is telling me 1/2 divided by 1/2. Let's take 1/2 outside of parentheses, then 1 plus 1/32, right? So they cancel. This is telling me 1 divided by 33. 32 plus 1 divided by 32. And this is telling me 32 divided by 33. This is very nice, but now we can also solve this one using Bayes theorem, right? Let's do this. Let U is unfair coin and F is fair coin, right? So now probability of unfair coin to be selected is 1/2. That's same as probability of F. Okay, but probability of getting tail, if it's unfair coin, is 1, and probability of getting tail if it's fair coin is 1/2, right? Okay, now the question is asking us, if we have, what's the probability of unfair coin if we have 5 tails? Well, this is telling us by using Bayes theorem, 5 tails given unfair coin times probability of unfair coin divided by probability of 5 tail given unfair coin times probability of unfair coin, and plus probability of 5 tails given fair coin times probability of fair coin. So I should have written this one more clearly, but that is the denominator, right? Okay. So this is going to be equal to, then, well, probability of 5 tail given unfair coin is independent of each other, so indeed that's going to be probability of tail given U, like 5 times the power, right, times probability of U divided by probability of tail given U, 5 times probability of, well, let me indeed write this in the next page. So I should have, I'm going to write this part again. That means, okay, probability of 5 tail, probability of u given 5 tail is equal to probability of 5 tail given u times probability of u, and divide by probability of 5 tail given u, probability of unfair coin plus probability of 5 tail given fair coin times probability of fair coin, right? So I'm going to write this one again real quick, that this is because each time is independent of each other. We can write this probability of tail given unfair coin to the top power 5, probability of unfair coin divided by probability of tail given unfair coin to the 5, probability of unfair coin plus probability of tail given fair coin, probability of to the 5 times probability of fair coin, right? Fair coin. Okay, this is telling me, because now we know this is 1, this is also 1 over 2, this is telling me 1 times 1 over 2 divided by, and this part is 1 times 1 over 2, and plus this is 1 over 2, and this is 1 over 2. This is going to be 1 over 32 times 1 over 2, and that we will get again the same answer, 33. Okay, that's it. See you in the next interview question.